In this session, I want to talk about how I work when using a camera. It can be any kind of camera, 35 millimeter, 124 by 5. This is the 4 by 5 Graflex. And when you do this film test that I'm recommending, or at least if you're going to follow what I do with film testing, it's important that we photograph a negative that is large enough area so that it can be measured with a densitometer, the aperture being about 3/16 of an inch in diameter. So we need a fairly large area on the negative to be measured with the densitometer. What I'm going to recommend is setting up a scene on a day that the lighting is fairly consistent. If there's a lot of clouds in the sky, it'll change your light level reading. So you want to probably go with a day when there aren't any clouds in the sky. And a fairly bright situation. In my case, I set up a scene in a backyard where there's sunlight and shadow. And I put large pieces of cardboard, garbage cans. This is black velvet. This is tin foil, angled so that the sun is reflected right into the camera. I wrinkle the tin foil, and it gives me a very strong reading. And after I set up a scene like this, in this case I used a 2 1/4 by 2 3/4 inch camera. It might have been 2 by 3. One of my large medium format cameras. And I come in close enough so that when I get the negative, which now measures this large, the areas are large enough so that I can measure it with a densitometer. That's important. If you're shooting 35 millimeter, what I would do is shoot one frame here, another frame here, another. So 3 successive frames would produce the whole scene, and it'll be large enough on your 35 millimeter film so that it can be measured. So that's the main thing. And another thing is to use film that you're going to be using. I mean, you can do this test with any number of films and any number of developers, but use the developer you're comfortable with and use a film that you're comfortable with. Again, set it up so that it's not windy. If it's windy, then these things get blown around, and which happens to me a number of times. But this is just a piece of white foam that gives you a good amount of detail in high values. And then I take a digital capture of this scene, and so I have this color rendition on digital film or digital file, and I make a quick I take a piece of paper and I jot down these measurements. This is what the meter read. Now in this case I'm using a Pentex spot meter, which will give you a digital readout. 17, the difference between 17 and 16 would be 1 stop. If you see a dot after a number, that's each dot is 1/3 of a stop. So most meters will only be accurate up to 1/3 of a stop. And any number of these objects can be placed into the midtones. So the object of this test is to process the film given a certain amount of agitation, temperature, and time, so that you know what you're going to get after you process, wash, and dry your film. We want at least a density range of about 1.6, 1.65 in order to get black to white on our black and white print. The session 1 hopefully covered that. But important as well is we want to get our detail to be easily seen between a density range of 0.75. So you're not going to see detail in the black velvet. It's going to produce your maximum black in the print. But the shadow detail underneath here to here is going to produce your easily seen detail. We want that density range to be 0.75. Again, that was covered in session 1. But we need a greater density range than 0.75 in order to get black to white. And approaching white, you're going to see a little bit of detail that's not easily seen, but it'll be there. And the shadow detail, you need to be able to have some shadow detail, some sense of substance there. Now, in terms of the zone system that was developed by Ansel Adams, he specifies that between zone 3 and zone 7 is where your detail is going to be seen easily. So I'm suggesting that 0.75 density range is what you want between 3 and 7. 8, 9, 10 approaches white. That's where your high value detail is. 10 is going to be pure white. Zone 2 and zone 1 is zone 1 is going to be your black, and zone 2 is going to be where your deep shadow detail is, where it's not easily seen. When I get to the third session and we talk about film masking, that's when we're going to bring up the detail in zone 2. That's the most common way of using film masking. Although film masking will allow you to approach other zones as well. But that's what I'll be talking about, enhancing the detail in zone 2 and still maintaining a good zone 1. That comes in the third session. Okay, so back to this. These areas that you measure, it's important that you write this down, because when you process the film and you measure the densities on your negative on the densitometer, you need to refer to these because we're going to plot this data. Okay. Like I said, any one of these zones can be zone 5. Okay. And what I did, here's this guy. This has my other data on there. I used Tri-X. I rated ASA 320. The exposure was 1/25th of a second at f12.5. I processed in microfilm, diluted 1 to 2. The temperature was 70 degrees. And I processed for 8.5 minutes, and that was my normal. Okay? And this was what I designated as zone 5, which fell in this corner of this board, and it gave me a meter reading of 12 and 2 dots, 12 and 2/3 of a stop. Okay. Now it's not possible to put down all these cardboards, garbage cans, whatever, background fences, whatever you may put, and get them to fall exactly on a specific zone. You probably will wind up with a scattering of zones that are close to one another. And so this is perhaps one of the reasons why this isn't done in a zone system. Mostly when you're dealing with testing in the zone system, you're shooting single sheets of zones, just one sheet of zone 1, zone 2. but it's very time consuming to do that. And this is more applicable. This is what reality shows when you're out in the field with your camera shooting. You're shooting a single exposure with a numerous number of zones within it. So I suggest again that we shoot it so it's large enough that you can measure it. One exposure you can measure, or in the case of 35 millimeter, 3 exposures can be measured on a densitometer, and you can get all 10 zones. And we do that through interpolation of data. Okay, so I'll get back to that. So when I measured this corner, I had a meter reading of 12 and 2 dots. And it produced a density on the negative of 0.80. So this has all 3 readings. So after I processed the film, I was able to determine that that area gave me a density of 0.80. Okay. This was zone 0. It read 8 on my meter. This is 17. This was probably the highest reading. It gave me a density of 1.53. It was zone 9 1/3. This went higher, but it's so specular that it wasn't large enough. See, specular highlights are usually those things that can be measured on a densitometer. It might be the edge of a glass. You have a very strong highlight which is going to reproduce as pure white. But because that area is smaller than the aperture of a densitometer, you can't measure that. So I had a lot of that on this tin foil. And depending on where I placed this area, I would get erratic readings. It exceeded 1.53 in some areas, but I wasn't sure what zone it was. So I put an X there and I couldn't use that reading. I put uneven lighting, bad data. This was 16 and gave me a measurement of 1.42, and I designated it as zone 8 1/3. Now, I'll show you how I came up with these specific zones, okay? But in any case, again, set up a scene where you can put large pieces of flat, this is a garbage can, this is a fence, obviously, a large gray card, a lighter foam board that was pure white. I covered this corrugated cardboard with some white foam so that I could see detail here. The shadow creates a zone by itself, so this became zone 5, and that was zone 7. This is 12 and 2 dots, 14 and 2 dots, so 12, 13, 14. So that happened to fall right on a specific zone. Okay, so this is the trick I came up with many years ago. I thought of this. And I used it to develop a software program that my brothers and I wrote for balancing color film in a darkroom, making color negative from transparencies. Again, I had to make a grayscale from a color transparency and make a negative onto color material and measure on a color densitometer in order to balance color film. Eastman, Kodak, and everyone else supplied a silver step tablet, which, again, in the first session we talked about that. It covered a density range of 3.0, 3.15. And they used that for balancing color film, and it didn't work very well. So I came up with a way of balancing, coming up with a color negative balance for working from Kodachrome transparencies versus ectochrome transparencies, and eventually we included Fujichrome and so forth. And I had to make grayscales on all these different color materials to make my tests. And again, I couldn't get a linear grayscale on color film. Matter of fact, Eastman Kodak, when I was in Rochester, they asked me how I did this, and they kind of questioned what, but I didn't tell them. It was one of our trade secrets in our software. But the way I did it was I relocated my domains. Now this is graph paper. On the left here, from 0 to 2.8, this is where you would indicate the density that you get on the densitometer. And here are your steps. Here's your steps. Step 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And these are equal distance apart. But because my grayscale was not linear, I had to relocate my domains. So depending on the grayscale, you would plot not on one, you would plot either, you might be plotting in between 1 and 1/3 stoppers. So these are the domains that I created for this graph paper, for this scene. And it follows the readings I got off of my spot meter. So the meter readings that you take with your meter, you may have to walk up to each one of these objects to measure them if you're not using the spot meter allows you to look at it through a lens and pinpoint that area that you're going to read. But if you don't have a spot meter, you can walk up to these areas and take separate individual readings and then write it down. You could do a rough sketch of this. In my case, I just made a digital print, and I wrote on my digital print the spot meter readings I got for each item. Then on graph paper, you can plot where so in this case, zone 5 was 12 and 2 dots. So that's where zone 5 fell. Now in this case, 14 and 2 dots is 7, zone 7. So on 7, I was able to plot right up here. So if I did get a reading of 1.16 in zone 7, here in zone 7, I go up to 1.16 and I make a mark there. That's where the data fell. 5, and would fall accordingly. If I had all these individual readings which fell in between zones, I would plot accordingly. So I have data scattered throughout, and then when I plot it, see all these data points with a French curve, you connect these dots and you come up with these plots. So even though I don't have data at zone 10, it's interpolated. As I follow the curve, I can predict what zone 10 would have been. Even though I don't have data exactly on zone 1, I have interpolated data for zone 1. So this is how we, one of the things we did to devise our software program in the 80s, when I came up with color balance of color negatives. So every software program had a different domain, set of domains for each grayscale we supplied. That's why every program was individually made. It was coupled with that particular grayscale, because there was no way to make color grayscales exactly the same. It's amazing to me that the black and white grayscales are as linear as they are, that Kodak made. I mean, Kodak was a great company. They did a lot of great things. But this is how we solved that problem, by making individual domains. So, pretty technical, but I hope it makes sense. Now,